Hey guys, it's Miss Adams, and we're going to be looking at the Unit 11 test review. And we're going to start off with page 1. And if you notice, it's going to say to solve these quadratic functions using different strategies. And in Unit 11, we learned 3 different strategies. So we learned how to use solving using the square root method. We learned how to use the quadratic formula. And we also learned how to solve by factoring. So we're going to look at those 3 today on this video. And the first one it says determine the solutions of the function using the quadratic formula. So in order to utilize the quadratic formula, we've got to be able to identify A, B, and C. So our A value in this case is 2. Our B value is -1. And our C value is -10. So all that we're going to really require here is that you guys show us how you put this into the quadratic formula. So I know x equals -b plus or minus the square root of b squared minus 4 times a times c, and all of that divided by 2a. Where in this case, we had a b value of -1, an a value of 2, and a c value of -10. Now that we have that, we can actually go to our calculator. So you can use the TI-30XS or whatever calculator that you have. And we're going to actually enter that in to our quadratic formula, or enter that quadratic formula into our calculator. So make sure that you're using that numerator over denominator button. That will help you out tremendously in this case. So we have that a value of 2, that b value of -1, and the c value of -10. Guys, we're not requiring you to simplify it from here. What we really want to be able to see is that you've plugged these values in. So remember, in your calculator, you can't put the plus or minus symbol, but you can put one value and then the next value. So what we're going to do, when we separate those roots out, if I were to add, I know that if I use addition, I'm going to wind up with x equals 5/2. So from that addition, I've got x equals 5/2. Or you could say 2.5. And that would be one of my solutions. And then the negative solution is going to give us that x equals, or the subtraction solution is x equals -2. So let's do that again on number 2. It says determine the zeros. So anytime I see solutions, zeros, roots, those are all dealing with your x-intercepts, okay? So it says determine the zeros of the function using the quadratic formula. So I've got to identify my a, b, and c, with my a value being 2, my b value being 7, and my c value being -4. So I can rewrite this as x equals -b, so in this case -7, plus or minus the square root of 7 squared minus 4 times 2 times -4, all divided by 2 times 2. So I'm just going to plug those values in so you guys can see them. And then I'm going to enter it into my calculator. So just be careful, guys. If you see parentheses where I've written them here, you also want to put those parentheses inside the calculator as well. So I had the a value of 2, had that b value of 7, and c value at -4. So from the positive side, we've got x equals, so that's one of my zeros, it's going to be x equals 1/2. Or you can say 0.5. And from the negative side, we can say that x equals -4. Or when we subtract it, we had x equals -4. So guys, that's solving using the quadratic formula. The next one we want to do is solving by factoring, because number 3 says determine the roots of the function by factoring completely. So when we factor, the first thing we always look for is a greatest common factor. So in this case, my greatest common factor is 4. So I'm going to factor out a 4 from both terms. And that's going to leave me with 4 times x squared. And then 64 divided by 4 is going to give us 16. So I got x squared, let's see here, minus 16 equals 0. And now I can factor this x squared minus 16 because it is a difference of 2 squares. So I'm missing that middle term b. But I know x squared is a perfect square, 16 is a perfect square. So my factored form here is going to be 4 multiplied by x plus 4 and x minus 4. Because once again, that 16 is going to break down to 4 times 4. X squared breaks down to x times x. There's subtraction in between. And now if I'm solving by factoring, I need to set each of my factors equal to 0. This is the zero product property. So if one thing equals 0, then I know at least one of its factors must equal 0 as well. So I can say 4 equals 0, x plus 4 equals 0, and x minus 4 equals 0. And from here, can 4 ever equal 0? No, so this is not a solution. So I know that 4 equals 0. I don't even have to worry about it. That's just, we've got that greatest common factor of 4. So I don't even have to set that a value equal to 0 because it doesn't contain a variable. Now my other two factors. I've got x plus 4 equals 0, so I'm going to subtract 4 on both sides. And that'll give me my first root of x equals negative 4. Then I've got x minus 4 equals 0, so I'm going to add 4 to both sides. And that gives me my second root of x equals positive 4. So those are the two roots there. Number 4 says determine the x-intercepts of the function by factoring completely. So this has also told us to factor. Remember, we've now got a trinomial, so I've got to do my factor chart. I've got to find my GCF. In this case, my GCF is 1, so there's really nothing to factor out there. I got to find my a, b, and c values. Then I got to find one number that multiplies to a times c, and then it also adds to b. So in this case, our b value is negative 4. Our a value is 1. And our c value is positive 4. So I've got to find two numbers that multiply to 1 times 4, which is just 4, but add to a negative 4. So I know the factors of 4 are 1 times 4 and 2 times 2, but I want them to add to be negative, multiply to be positive. So I'm going to make both of those factors negative. And the only pairing that works here is negative 2 and negative 2. So negative 2 plus negative 2 yields negative 4. I'm going to use that to expand a trinomial into a 4-term polynomial. So I've got x squared minus 2x minus 2x plus 4 equals 0. I've got 3 terms, so I can now factor by grouping. I'm going to group the first 2, group the second 2. From the first grouping, I've got x squared minus 2x. I'm going to factor out an x. And that's going to leave me with x minus 2. From the second grouping, I'm going to factor out a negative 2. And that'll leave me with x minus 2 again. So my factored form here is x minus 2 times x minus 2 equals 0. But it says determine the x-intercepts of the function by factoring completely. So I now need to set each of these factors equal to 0 using the zero product property. But guys, notice these are both the same factor. We have x minus 2 and x minus 2. I'm going to add 2 to both of these equations, and I should wind up with the same value, that x equals 2. So therefore, the only x-intercept I have in this case is at 2, 0 for this function. Remember, guys, if you only have one x-intercept, that x-intercept is also going to be your vertex. Now, we're going to move on to number 5. And if you look at number 5 and 6, these are already in factored form. Guys, if I were you, I would not convert them to standard form. They're in factored form, so solve them using the zero product property. I can say I've got 2x minus 1 times x minus 2. And I'm just going to set both of those factors equal to 0 and solve. First step on number 1 is I'm going to add 1 to both sides. So I've got 2x minus 1 equals 0. Add 1 to both sides. That's going to leave me with 2x equals 1. Then I'm going to divide by 2. And and that leaves me with x equals 1/2. So if I write out that x-intercept, I could say 1/2 comma 0 or 0.5 comma 0. My next x-intercept is pretty easy to find. All I have to do is add 2 to both sides. So that leaves me with x equals 2 and x-intercept of 2 comma 0. So my two x-intercepts there are 0.5 comma 0 and 2 comma 0. Same idea with number 6. It says to find the x-intercepts of the following. So I'm going to have 2x minus 6 equals 0 and x minus 3 equals 0. For the first one, I'm going to start by adding 6 to both sides. That's going to leave me with 2x equals 6. Divide by 2 on both sides. So that leaves me with x equals a positive 3. And that leaves me with the x-intercept of 3 comma 0. For the next one, it's only a one-step equation, so I'm going to add 3 to both sides. That also leaves me with x equals 3. So my only x-intercept in this case, even though they looked a little different, they yield the x-intercept of 3 comma 0. So guys, we're going to do the same idea with number 7. And then in our next video, we'll go into applications with quadratic functions. So number 7 says factor completely and solve for the solutions. So remember, once again, when we factor completely, we always need to look for a GCF. And then we can create our factor table. So if I'm looking at these functions, I've got 3x squared minus 15x minus 18. Looking at those terms, I know that they are all divisible by 3. So 3 is going to be our GCF. So I've got 3 multiplied by x squared minus 5x minus 6 is equal to 0, leaving me with a new a value of 1, a new b value of negative 5, and a new c value of negative 6. 1 times negative 6 gives me negative 6. So I've got to find two numbers that multiply to a negative 6 but add to a negative 5. The factors of 6 are 1 and 6 and 2 and 3. So guys, this can get a little tricky because we've got to focus on our integers here. Notice they're multiplying to be negative and adding to be negative. So therefore, one of my factors here needs to be positive, one needs to be negative. And it looks like since they're adding together to be negative, our larger factors need to be negative. So if I do 1 plus negative 6, that indeed yields negative 5. Guys, 2 plus negative 3 is going to give you a negative 1. That is not the factor set that we want here. So now I'm going to break negative 5x into 1x minus 6x. And I can bring down the x squared and the negative 6. Guys, I'm going to save that 3 for later. I've got 4 terms, so I'm going to factor by grouping. If I look for the GCF out of the first grouping, I'm going to have x. And that's going to leave me with x plus 1 inside the parentheses. My second grouping, I'm going to factor out a negative 6, which is going to leave me with an x plus 1 inside the parentheses. Those are the same thing. So now I'm going to go to the left-hand side here and write out my factored version, but I've got to start off with my greatest common factor of 3. Then I know it's going to be multiplied by x plus 1 times x minus 6. But guys, it didn't say just to factor completely. It said to solve. So if I said just factor completely, you could stop there. But I also want you to solve for the solutions. So I'm going to set each of those factors equal to 0. So I've got x plus 1 equals 0, x minus 6 equals 0. And guys, I'm not even going to set the 3 equal to 0 because 3 can never equal to 0. That just doesn't make sense. So now this becomes just one-step equations. I'm going to subtract a 1 from both sides. So that gives me my first solution that x equals negative 1. I'm going to add a 6 to both sides. So that gives me the second solution that x equals a positive 6. So guys, those would be your two solutions here. All right, in the next video, we're going to start going over some of these application problems. We'll do one more quadratic formula problem, and then we will also just wrap up with some solving by square root method.